Hey there, welcome to Beauty at Work. We're in between seasons at the moment, so please check out this clip from one of our episodes. When we think of the applied sciences, we usually think they're important because they're useful. But can they also be beautiful? In this clip, public health expert Dr. Marcia Otto shares what inspired her career path from theoretical physics to epidemiology. And she discusses where she finds beauty in the work she does today. Check it out.
As I began to study physics, and I remember, being interested in calculus and mathematics doesn't mean that it's easy, right? And so, as I mentioned, I was working full-time from early in the morning until about 3 p.m., and then I would go straight to the university, and my course would be afternoon and evening, and I would leave at 10 p.m. Every day. And so I began to study a lot and study long hours. And by the mid of my midterm, around 2-3 years into the program, it was clear to me that, in physics, there is these two very specific branches. One is the theoretical physics, and the other one is applied physics. And usually theoretical physicists, they spend a lot of time understanding problems that are abstract, right? They spend a lot of time in this world where you think about the fifth dimension, things that are really difficult to study and grasp in reality. And I saw more and more the potential of physics to really help us understand concrete problems. And I found myself more and more interested in applied physics. I still remember my second to last semester, I had a teacher, she taught quantum mechanics. And she had just come back from a sabbatical because her grandmother had cancer. And she moved to this small town in Brazil where her grandmother was going to be treated. And she was a nuclear physicist. And she said, I want to be there with the physicians. Back then, cancer treatment in Brazil was very much, you would receive a very high dose, a lot of side effects. And the main goal was to make sure that you killed all the cells. And as a result, many organs at times were affected as well. There was not a lot of very specific, precise estimation of dose of radiation, for example. So she went there. Her grandmother was in her 80s. And the doctor said at first that there would be lots of side effects because of her age. And they were expecting her grandmother to have a difficult journey. So this teacher of mine moved there, and she spent the whole six months with the physician. She said, I am a nuclear physicist. I can help you calculate the dose for my grandmother for that specific case. And that she did. And her grandmother had minimum side effects. The whole treatment went much better than expected initially. And by the end of those 6 months, her grandmother had ended treatment and she came back to teach. And so the first day of class, she was telling us this. And she was also telling us how at the end of her grandmother's treatment, the doctors came to her and say, look, we need to work together. There is so much we can do. What you brought, the skill set that you brought was so valuable. And she said, no. I'm sorry, you don't understand. I'm here because of my grandmother. I am a theoretical physicist. I am not interested in anything that is concrete. I like my field and interest is to really do theoretical physics. And she's telling us in the classroom with her eyes super satisfied with her answer, right, to the doctors. And I looked at her and I said, wow, that is not what I want to go. I do not want to be a theoretical physicist, if that is what the field entails, I want to. So her whole experience and her excitement in having helped her grandmother helped me clarify that I really wanted to pursue something that was more applicable, a science that could be used to help society, to help individuals, and so on. And so I finished my, the only intuition that I had at the end of my college was that I wanted to pursue applied physics. And I had some research experience on nuclear physics. So by the end of college, it was clear to me that working full-time and studying full-time was too hard. So if I wanted to pursue a graduate degree, I wanted to apply for scholarships so that I did not have to work. And so I applied to a couple of programs in Brazil, and one of them was a program that was evaluating environmental science, which was a big growing field back in the early 2000s. And this program would bring professionals from different areas to study the increasing problems of the environment. And so I applied to that program. I was very fortunate to obtain a full scholarship, and I was there being trained in nuclear physics applied to environmental problems. So I would come from the physics angle. I would be working with engineers, sociologists, architects, people working with different environmental problems. And I would have a strong physics training and then apply that to the problems of the environment. And so in that program, I became more and more aware that lead in water was a very big problem, especially in poor communities outside of São Paulo City, in which I now resided. And so my theoretical problem was to derive equations to estimate the intake or absorption of lead in biological samples. So that was the project for my master's training. And so as I was part of that program, I was studying water pollution, I was studying air pollution, I was involved in large discussions about environmental problems in Brazil. And so I understood in my studies that individuals who were at highest vulnerability to health problems due to lead exposure were children. So their brain is under development, right? And what happens with lead exposure is that it attacks the neurons. And so children undergoing neurological development, they were more vulnerable to that exposure early on. And so I defined a study. I said, okay, I want to study, if I am to quantify, I want to quantify exposure in children in certain regions in Brazil where they are at higher risk of lead exposure. The second thing that I learned was that bone structure is the place where lead is stored in the body. And because I was interested in children, I also understood that teeth, like milk teeth, would be a great indicator, a great sample to obtain to measure and quantify lead exposure that would occur in childhood and therefore be more relevant to long-term health consequences. So I developed my whole model using teeth as a biological sample, And then I would go to the lab. So I went to clinics, dental clinics in the outskirts of São Paulo city to collect teeth that children would be having removed in those clinics. And that I used in the lab to quantify lead and with the whole estimation of how much they were being exposed. And I also went to a different group of children who were less exposed to lead because of the water sources. And I compared those two groups. At the end of my master's training, when I was defending my thesis, I was told that they needed to find an epidemiologist to be part of my evaluating committee because the work that I had conducted was a pure epidemiologic study. And that was the first time that I heard that word.
That's great.
And so it was very clear to me that I wanted to learn those methods. I wanted to pursue that path. And that's how I ended up applying for a PhD program in epidemiology here at the University of Texas, and then moved to the United States.
Wow, that's really fascinating. And you've stayed with it since then. Have you found it satisfying as your journey has continued in this path?
Yes, it's such an adventure, Brandon, when you begin to follow a glimpse of an interest and very closely. I was reading your work and seeing the videos that you have put together on beauty, right? And I have recognized one by one this beauty of understanding has been really very, very striking to me. So when I arrived at the University of Texas, there was a large program in environmental health. The department was being restructured. There was not a lot of scientific projects on heavy metals and effects on health, which was my primary interest. But then I was very early on introduced to a professor who was doing work on diet and the effects of diet on heart disease and chronic diseases. And I explained to her my work and my passion to understanding especially effects of heavy metals on health outcomes. And she said, I do not have any project on heavy metals, but I do study essential metals. Would that be of interest to you? And just like that, I said, of course, that would be of great interest, because it's exactly in the absence of good nutrition and in the absence of essential metals that those heavy metals become even more dangerous, because the human body is so fascinating that it uses everything it has to do the work, right? So neurons, in the absence of calcium, which is a very important essential metal for the brain, the body would use any heavy metal that we'll find. And so that's how I shifted to nutrition epidemiology, and the adventure began, right? Now I have a whole new road to explore, to understand, to really focus on in order to get to a final goal, which was really to help society, to help shift the health of populations.
Yeah. That's amazing. Talk to us about like the beauty you experience in your work today. What does that look like for you?
Yeah, it's a great provocation, because as a scientist, it's not that I go to work and I say, okay, today I'm going to look for beauty, right? But again, in becoming more familiar with your work, I quickly understood that it is these moments in which we grasp something, in which we the whole process of being able to grasp, to understand we human beings, limited beings, how is it possible that we can move from a curiosity or a broad interest in a certain problem and then refine that research question, right? Think about which metrics will be needed in order to evaluate that research question. Define a method, understand the statistics, or what is it that will take to address that question, all that step-by-step components all the way until we actually are able to see something. The whole process of being able to understand, to me, is fascinating. And that's exactly what I teach. So there are two super important components. First, I see myself designing a project, evaluating, going to the communities, collecting data, spending the time in front of the data, doing the data analysis, and then seeing something coming out of that process, right? That allows me to understand at a different, deeper level. And then at the same time, I am now teaching these methods, and I am seeing students undergoing the very same process, which is coming with an initial interest, being able to walk that path, especially understanding the methods and designing methods that will allow them to explore and address a particular research question. This has been fascinating to see some of the vibration that I experience in my research also in front of me in the classroom.
Yeah, what is that? How do you recognize that in the classroom? What does that look like when when you're able to see your research interests or the understanding that you find beautiful in science resonating with someone else? How do you glimpse that?
So I had this past semester in the fall, I was teaching an elective course called Nutritional Epidemiology. And so in that class, I bring my research, I bring others' research, and the idea is to just let's look at these studies. Let's understand what is being proposed in terms of research question, what was the methodology that they used, and what they found out. And one by one, this is an elective course, it's a small class. Last time I had about 16 students. And it's a new course for me, so I'm still exploring how is it that I present content and provoke students to think about methodology, right? And I had I'll tell you about two specific students. So I had student A and student B. And student A is a third semester master student, and he comes to the classroom slightly late every day, and he sits there and he's distracted, right? You can tell that this class starts at 10, he's very distracted, he's still landing and so on. And later I understood that he's constantly late because he works at night. He works at long hours at HEB to provide for himself while he's pursuing his degree. So student A is there, sitting there, has very, very curious student. He's very also interested in statistics, so he has studied lots of statistical methods. And we are there looking at his research, nutritional research. Day after day, I see student A waking up in front of the screen and starting to ask questions, question after question after question. And he's also started to wait for me after class and continue that conversation. And at one day he told me, I've been taking all these different courses, and I really love biostatistics, but I never understood how those methods were used to allow us to understand this piece of reality the way that you are explaining. I never saw the need, for example, for how a p-value could point to a particular path in which that mechanism is now something that we can explore further. And the moment I could see him becoming more engaged in the classroom, asking more questions, more excited because he saw a pathway through which his own interests and training could lead to a new direction, right? And I was extremely pleased because that's exactly what happens to me. It's contagious when you see that vibration of, okay, first of all, it's possible for me to understand something, and look at how much I can see now, right? That was phenomenal.
Wow. You said you had a second student?
Yes, my second student, I'll call her student X, and she is also very, very young. She's actually at her last semester, and she's still seeking, right? Students who come to the School of Public Health, they want to save the world. They don't want to be rich necessarily. They really want to do something that matters for society. And so she comes with a general interest in public health because she has a health condition herself. And she always wanted to understand, if I am to contribute to the prevention of this health condition, I would like that. And if public health is a field that I can pursue, that's what I want to do. So she's finishing her master's degree. She still hasn't really understood what she's coming next for her. And she's sitting there at my class. And again, I see her starting to ask more and more questions. I see her level of engagement. And at a certain point, kind of mid-semester, she told me, now I understand what I want to do next. And I said, what is it? She said, I want to be a scientist. I want to pursue a PhD degree. This was not something that I had initially in mind, but now I see the possibility, the opportunity, the power of these methods that I am learning to really help me pursue this field that I want, which is disease prevention, specifically the prevention of lupus, to help, individuals that are highly vulnerable. That possibility of grasping, even before, you grasp something and then you realize and you trust that that's possible. And therefore, I want to spend my energy, my time in that, betting in that possibility.
Beauty at Work is brought to you by Templeton Religion Trust. If you enjoyed this clip, go check out the full episode. And please take a moment to subscribe and leave us a review. It really helps get the word out about the show. Thanks, and see you next time.